Welcome back to my channel. Today we're going to work on the question match consecutive ones 2. It's a medium level array question. The question states, given a binary array nums, return the maximum number of consecutive ones in the array if you can flip at most 1, 0. Sorry, my cat is just beside me on my desk, making a lot of noise. So let's look at example 1. Input nums equals 1, 0, 1, 1, 0. So there's 2 zeros in this list, and basically we can flip either this 0 or this 0 to create the matched consecutive ones. If we flip this first 0, we'll have 4 consecutive ones, and we will output 4. And then if we flip this 0, we'll have 3 consecutive ones. And then that's not the match, so we don't return that. We just return 4 because this is the match. Looking at the second example, there's also 2 zeros. If we flip this first one, we'll have 4 consecutive ones. If we flip the second one, we'll have also 4 consecutive ones, so that's why we return 4 as our output. And looking at this question, the best way to solve this with the best time complexity is probably using a sliding window technique. So for sliding window, let's first define our pointers. We'll have a left and right pointer, both initiating at 0. And then we can define our max window. Currently the max window is at 0, and also we can count how many zeros there are. So also at 0 in the beginning. So let's start defining our window, sliding our window. So while our right pointer hasn't gone through the list yet, is still less than the length of the nums, then we'll set up some conditions to see when the window is right. So the first condition, like when we're sliding a window, the left and right pointer both start at 0, and that's first. And then the left stays here while we slide the right to the left. And then let's see if the right pointer encounters a 0. So if let's say nums right is at 0, then what do? We want to increase our zeros counter, right? Equals 1. We increase it by 1 because now our right is at a 0 and there's 1 0. And then at this point we want to also increase our, this is how we move our right pointer, like we increase right by 1. Also we want to check if we have more than, like if we have 2 zeros at any point in our window, and that's when we want to shrink our window. That's the condition to shrink. So if our right keeps going, it's at 1 0, it's okay, and then it reaches here, and then suddenly there's 2 zeros. We want to decrease our left to like this one, right? So that we only contain 1 0. So basically, to write that in code, if zeros at any point is equal to 2, let's do while zeros equals to 2, and if our left, if nums left is at a 0, then we want to decrease our zeros by 1, and then we want to move our left pointer to the right by 1. And at the end, if we're at the perfect condition where there's only 1 0 in the max window, then we want to update our max window to see the length of it equals max window equals max of max window from before or initialize compared to our current window size. So our current window size is the right pointer minus the left pointer plus 1. We plus 1 because in Python the list index starts at 0, and then let's say if right is here, that's index 1, right, and left is here, that's index 0. So 1 minus 0 equals 1, but actually we have 2 in our list, so we just want to add this 1 in the end to make it the actual length of our list. of our window, I mean. So in the end, we want to return our max window. Yeah, so this is how I would solve this question. As for the time complexity, this would be ON, because as we slide through our window, we only really go through our nums list once. Space complexity, we don't really use any additional space, we just have a bunch of variables here tracking, so it's also O1. And that's it for this question. Thank you so much for watching.